So this number 2, we're given a vector value function, and we want to sketch its graph. Well, so I'll start with these two, and what I see is that this gives me x equals t and y is t squared, so y equals x squared. That'll sort of be the shadow of my graph here in the x and y plane on the floor. It would make a parabola if I didn't have anything else, but what's happening is the z is going to be rising above that parabola, so the z is coming out something like that, and then around this way like a parabola. But that's the shadow, that red dotted line. So that would be my sketch of that. And then I'm asked to find the curvature, and I know that the curvature is given by this formula, magnitude of r prime cross r double prime, and that's divided by magnitude of r prime cubed. So I need r prime. That's going to be 1, 2t, 2t. I need r double prime. That's going to be 0, 2, and 2. And I need the cross product of that because I will need the magnitude of the cross product. So r prime cross r double prime. I'll just use that little quick shortcut method of covering up these first two and taking the cross product here. Well, that's going to be 4t minus 4t. That's going to be 0. Covering up the middle two, I get 2 minus 0. Well, I know that it's 2, but I always put the minus on the middle one. And then covering up the last two, I get 2 times minus 0, so that's just going to be 2. And so now I can plug into that formula for curvature and then evaluate it at 1. So give myself a little room. So I get that the curvature for this value of t is going to be magnitude of this vector, that is the square root of 0 squared plus negative 2 squared plus 2 squared. And in the bottom, it's going to be the square root of this vector, which is 1 squared, so square root of 1, plus 2t squared, that's 4t squared, plus 4t squared, and then I do have to cube that. Okay, so, and then I'll plug in 1 when I'm done. So I get, in the top I get square root of 8, no t there. Let's go ahead and get this bottom worked out. That's going to be the square root of 1 plus 8t squared. And then I'll cube that. I'll go ahead and I can plug the t in now if I want to. And so I will. And what I get, well, there's no t here. Square root of 8 we can simplify to be 2 square root of 2. But when I plug the t equal 1 in, I get 8 plus 1. That's square root of 1 is 3, and 3 cubed is 27. So that would be the curvature for that particular curve up here when t is 1. Okay, so let's sketch this next one. Here we've got, first, we're given a vector value function. We're supposed to sketch it. I can see what happens here is x is 1, but my z and my y, what happens with that is they're equal to each other. Right, you can see they're both t squared. So that says, for example, when I put in 1, I'm going to get 1 and 1. When I put in 2, I'm going to get 4 and 4, and so on. So x has to stay 1, so the x can't stray from this dotted line. And I can see that because these are t squared, the y and the z will never be negative. So they'll get to here, and that's as far as they'll go. When I put in 0, I'll get 0, 0. But if I put in positives or negatives, I'm squaring them. And so what I get is this comes away from here at a 45-degree angle because the y and the z have to stay the same. Now it's staying right above this line everywhere, so I'm going to draw it solid now. So it's always positive. It's a line, and it's above this line all the way along. Now we want the arc length parameterization of r. So remember what that means is I'm going to call this S. I'm going to integrate from 0 to t of the magnitude of r prime. And so what I get, taking r prime, let's go ahead and put that in. So this is going to be the magnitude of this vector. Well, up here, I can't see it, but it's the derivative of 1 t squared and t squared. So derivative of 1 is 0, derivative of t squared is 2t, and the derivative of t squared is 2t. And so I'm going to take the, and this should be u since I'm using function of u just to avoid the ambiguity there. So it's 2u and 2u. So now I know the magnitude of that is going to be the square root of 0 squared plus 4t squared, u squared plus 4u squared. And so that's going to give me 0 to t of square root of 8t squared. I keep putting t's, but it's u squared du. And that I can actually take the square root of, so there's no extra work here. I can take the square root to get 2, for the square root of 8, it's going to be 2 square root of 2, and the square root of u squared is u, so I'm going to get 2u square root of 2 du. And now I can integrate. When I integrate this, I get u squared over 2. That's going to cancel this 2 out, so I'll still have a square root of 2 evaluated from 0 to t. And plugging that in, I get square root of 2 t squared. So s equals square root of t, square root of 2 t squared. And now I plug in 0, you're going to get 0, obviously. I didn't put that down. And I can solve this now. Solving for t in terms of s, I get s over the square root of 2 equal t squared. And I take the square root of both sides, giving me t equal to the square root of s over square root of 2, which you can do a double square root if you like, but that's really the 4th root. It's a half power and a half power, so whichever you want to write that. I'll just go ahead and say it's the 4th root. Okay, and so that I now take and substitute back into my function, and what I get is that my new parameterization in terms of s is going to be 1. And everywhere I have a t squared, I'm going to put this square root of s over the 4th root of 2. So I get square root of s over 4th root of 2 squared and square root of s over the 4th root of 2 squared. Squaring these, I get s. Now this 4th root, if I had left it as the square root of the square root, it just gets rid of part of that. It gets this becomes 2 to the 1/2, so it comes back to a square root of 2, and this goes to a square root of 2 as well. So that's the parameterization that will output the point. You give me the distance you want to travel along this line, and it'll output the point that's on that line. For example, 0 is pretty easy to see. When I'm distance of 0, I'll get 1, 0, 0, which is that point. But if I'm 1 unit along, it turns out I'm at the point 1 over square root of 2, 1 over square root of 2. That would be the coordinates of that point, and the distance to that point would be 1 unit. But that's the parameterization, which is what we were asked to find.